In this video, I'm going to run through some solutions from our combinations worksheet. I'm starting with question 18, and in question 18, there is an exam paper and a student has to answer out of the 10 questions available. In part 1 of the question, they have to choose any 8 questions to answer, and there are 45 ways in which this can be done. In part 2, there's a restriction. They're breaking the question paper up into the first 3 questions and then the other 7 questions. And they want us to answer exactly 2 out of the first 3 questions. So from those first 3 questions, I must choose 2. From the remaining 7 questions, well, I have to choose enough to make up the total 8 questions that I need to answer off the paper. I've chosen 2 already. I need to choose 6 now. I need to choose 2 questions from the first 3 and 6 questions from the remaining 7. So I'm going to multiply these 2 things together. 3 choose 2 is 3. 7 choose 6 is 7. And so my answer here is 21. On to part 3 of the question. Again, they're breaking the paper up into the first 3 questions and then the other 7 questions. And they're saying that I must answer at least 2 questions from those first 3 questions. So there's a couple of different scenarios that are possible here. I could decide to choose 2 questions from those first 3 questions, in which case I'd have 3 choose 2. And if I'm doing that, then I'm choosing 6 questions from the remaining 7. Or I could decide to choose all 3 questions from that first 3. And I could then have to choose 5 questions from the remaining 7. So in that case, I'd choose 3 questions from the first 3, and, which means multiply, 5 questions from the remaining 7, and I can work out my answer for that. And this comes out as 21. And since I want either this first scenario or the second scenario to happen, then what I'm going to do is I'm going to add those 2 together, because don't forget, in anything to do with probability or permutations or combinations, the word or indicates addition. So my solution here is going to be to add these 2 options together. And so there are 42 ways in which I can choose at least 2 of the first 3 questions. On we go to question 19. Question 19 deals with a pack of playing cards, so you need to be reasonably familiar with how this is set up. And in this question, we're told that a man is dealt 5 cards from a pack. So the first part of the question then asks us to find out in how many ways will the cards contain exactly 2 kings. So let's think about what can happen here. I've got 4 kings available to me in the pack, and I want to get 2 of them. But not only that, I must also receive the other remaining 3 cards in my hand. So I also have 48 remaining cards to choose from, and I have to get 3 out of that group. I want this to happen, 2 of the kings and 3 other cards, so I'll multiply to get my answer. And in this case, my answer is 103,776. Part 2 of this question is a little bit like part 3 of question 18. We want to know in how many ways will the cards contain at least 1 king. So I could have 1 king, or I could have 2 kings, or I could have 3 kings, or I could have 4 kings. I don't have the option of having 5, obviously, because there's only 4 kings in the pack. So I need to do a calculation for each of these. So for my option there for 1 king, well, that means I'd choose 1 out of the 4 kings, and then my remaining 4 cards would come from the rest of the pack. That should say 4, sorry, not 3. And I can work that out, and I get 194,580. The 2 king option I've already calculated, it's up here, and the answer for that is 103,776. Next, I have my 3 king option. So for 3 kings, I've got 4 kings. I'm going to pick 3 of them, and then from the remaining 48 cards, I need to pick 2 more cards. So I can go to my calculator, and I get 4,512 for this answer. And finally, my last option then is that I have 4 kings. So I'd have, from the 4 kings, I'd have to choose 4 of them. And then I would also have to choose 1 remaining card from the other 48. And in this case, my answer is just 48. And then, because I want one of these scenarios to happen, it can be the 1 king or the 2 kings or the 3 kings or the 4 kings. I'm going to add those together to get my final solution. So don't forget that guy there, the 103,776. And for that, I'm getting an answer of 302,916. I'm just noting that that does not match the solution that they've given me in the solutions sheet. So I'll double check that and come back to you on that one. In question 20, we've got a club that has 8 women and 6 men as members, and we have to pick a team of 3. In the first part of the question, there's no restrictions. So it's just going to be 14, because there are 14 people, choose 3. When I work that out, I get an answer of 364. Part 2 of the question says that the club captain must be on the team. So the club captain is one of those people that we've already mentioned from these 8 women and 6 men. So they're in, so the captain is in. So I've got 13 people left, and I must pick 2 of those people to make up my team. And the answer for that is 78. Part 3 of the question says that there must be at least 1 woman on the team. So there's a team of 3. So I can have 1 woman and 2 men. Or I can have 2 women and 1 man. Or I can have 3 women. So I can have any of these setups. So it can be the first or the second or the third. So I'll have to work each of those out and then add them together. So if I want to have 1 woman on the team, that means that from the 8 women, I must choose 1 person. And from the 6 men, I must choose 2. So I can work that out and I get 120. For the next option, I can choose 2 women. So 8 choose 2 and just 1 of the men. So 6 choose 1. And that's going to give me an answer of 168. And then finally, I just choose 3 women and no men. So I don't need to worry about the men there at all. And 8 choose 3 comes out as 56. And then I'm going to add those together to get my answer. And I'll get 344. Part 4 says there must be more women than men on the team. So going back to look at my previous part of the question, that means I'd be happy with this setup where there's 2 women, or this setup where there's 3 women. So in that case, I'll just add those 2 final values together and I'll get an answer of 224. Okay, I've had to relocate because it was getting dark over there. And now we're on to question 21. So we're asked to find the value of n if n choose 2 is equal to 91. So now I could do this through just the process of trial and error, but that could be a very long process altogether. So it would be better if I could do a calculation to work it out. So before we do that, let's just remind ourselves of how NCR works. So for example, if I have 6 choose 2, what I would need to do to calculate it is start with 6 on top, multiply by the next number down. I only want 2 values there because of the number 2 there at the bottom. My R is 2. And on the bottom, I'll do 2 factorial, so 2 by 1. And then I work my answer out, and in that case, it would be 15. So I'm going to use a very similar process now for my calculation in question 21. The only difference is that I don't have an exact value for that n, but that's no problem. I can still actually do the calculation. So what am I going to do? So for n choose 2, I'm going to start with n, and then I'm going to multiply by the next number down. So how did I get down from 6 to the next number? Well, I took 1 away from it. So 6 and then take away 1 is 5. If I've got n and I want to take 1 away from it, well, that's just going to be n minus 1. And on the bottom, it'll still be 2 times 1. And I know the answer is 91, so equals 91. Now, I'm not overly keen here on the multiplication symbol. It'd probably be quite nice to write that as n bracket n minus 1. And on the bottom, 2 by 1 is 2, equals to 91. And I need to just rearrange this then slightly in order to be able to solve it. And what's going to happen is it's going to turn into a quadratic. So n by n is n squared. N by minus 1 is minus 1n. And I'll bring my 2 across to the right-hand side and multiply that by the 91. And that's going to give me 182. And then I'll bring everything to one side. And I'm going to be able to factorize this and solve it. So I just have to find factors that will work for this case. And I'm going to end up there with n minus 14 by n plus 13 equals to 0. So I get 2 answers for this. I get n equals to 14 and I get n equals to minus 13. But just bear in mind with these questions that I'm always going to be dealing with positive numbers for my n and my r. So whatever values I have in my n choose r calculation are always going to be plus. So that means I can eliminate this possible answer, the n equals minus 13, and my answer is just n equals to 14. Okay? I'm going to go through the solutions for question 22 and 23 in a second, but if you weren't able to do them before, maybe pause the video now and give them a shot again and see if you get them correct when you play and check your answers against mine. Okay, so I'm going to do question 22 now. So I want to find the value of the natural number n if n choose 2 equals to 136. So this is very like that last question. So my NCR calculation is going to start off so as a fraction. On the top, I'll start with n, and then I'll multiply it by the next value down. So that's n minus 1. And I adjusted those two terms because the R value on the bottom is 2. So that number there on the bottom dictates how many terms I should include on the top. And then on the bottom, I'm going to have 2 by 1. And the answer is going to be 136. And now I need to just multiply this out and make a quadratic from it. So on the top, on the left-hand side, that's n squared minus 1n. 2 by 1 is 2, and I can bring that across and multiply it by 136 to get 272. And then I'll bring everything to one side and let it equal to 0, and then I'll factorize and solve. So at this stage, I have to find my factors. And I'm going to end up with n minus 17 by n plus 16 equals 0. And so my solutions are possibly n equals 17 and n equals minus 16. But of course, in combinations in our NCR notation, I can only have a positive n, so I can eliminate that n value straight away. And my solution is n equals to 17. Okay, so I just take the positive answer. And finally, we have question 23. And this is the same idea as 21 and 22, just a fraction different from it. We have got, in this case, n plus 1, choose 2, and that's equal to 190. So what might that indicate then? Well, again, I want to start at n plus 1. So I'll say n plus 1, and then I'll times it by the next number down. So again, to get to the next number down, I just take off 1. So if I take 1 off n plus 1, I'm just going to be ending up at n. And then at the bottom, I'm going to have 2 by 1, and the answer I've been told in the question is 190. So now I have to just multiply out for myself. So I'm going to have n squared plus 1n. I can bring that 2 up and multiply it by the 190 to get 380. I'll rearrange the quadratic so it's all on one side. And then I have to factorize and solve. So my factors then are going to be n plus 20, n minus 19 equals to 0. And so I've got n equals to minus 20 or n equals to plus 19. And again, just like before, I'll drop my marker. I'm going to eliminate my negative solution and only accept the positive solution.